Lesson 9.5. Okay, addition, subtraction, and complex fractions. So we've been dealing with rational expressions. Okay, rational expressions look like fractions, right? They have a numerator and a denominator. In 9.4, we did multiplying and dividing because it's a little easier to multiply and divide because it doesn't matter what's in the denominator. Okay, adding and subtracting are a little more complicated just because you have to worry about your denominators, okay? So if you think about fractions, right? You can add and subtract when they have the same denominator. You just add or subtract their numerators, okay? Same thing for rational expressions. Right, so if they have the same denominator, all you have to worry about is adding or subtracting their numerators and keeping the denominator the same. Okay, so the same expression in the denominator, add or subtract their numerators. So we have 3 over 2x minus 7 over 2x. Okay, well, they're both over 2x, so keep your denominator and just subtract your numerators. So negative 4 over 2x, and then simplify if possible. We'll divide both by 2. And we get negative 2 over x. Okay, same denominator, add or subtract their numerators. So we have 3x over x minus 4 plus 6 over x minus 4. Okay, well, they have the same denominator. They're both over x minus 4, so we're going to leave the x minus 4, and then the numerator, just add 3x plus 6. You could try to factor. 3x plus 6 would just be factoring out a 3. You would get x plus 2. Does not help us too much because there's not common factors to both. So you can't simplify anything out. So we would leave it as 3x plus 6 over x minus 4. Okay? So it's the same as when they have the same denominator. Okay? In a normal fraction. Just add or subtract their numerators. The difference comes when they have unlike denominators. So when you had a fraction that did not have the same denominator, the very first thing you needed to do was make them have the same denominator. Okay? The very first thing you need to do is find the least common denominator. Right? So to find the least common denominator, you want to factor as much as possible, then find what's missing, and multiply. Okay? Then once you have your least common denominator, you're going to rewrite your expressions using the least common denominator. We call it the LCD. Okay? So whatever you had to multiply by to get that common denominator, also multiply the numerator by it. Then they'll have the same denominator, so then you can add or subtract. with like denominators. Okay, so to see how this is done, right, we have 4 over 3x cubed plus x over 6x cubed plus 3x squared. Okay, so we need to rewrite these with the least common denominator. So 3x cubed is really just, you can't really factor it, okay? But 6x cubed, we can factor. We can pull out a 3. Not gonna have enough space. So that's going to be so if we factor out by taking out a 3x squared, then what's left behind is a 2x plus 1. Okay, so then looking at these two denominators, we want to figure out what this one has that this one's missing and what this one has that this one's missing. So when I look, I have a 3, okay, so we're good there. I have an x cubed, but I have an x squared. So this one, I need another x. So we're going to make it now x squared, x cubed. So now we've got 3x cubed, 3x squared, 3x cubed. Okay, so then what this one's missing is this 2x plus 1. So what I multiplied this fraction by was 2x plus 1, so I need to multiply numerator as well so the value doesn't change. And then here what I multiplied by was I just had an extra x. And then we can simplify them. So they'll have the same denominator. Okay, so this, I distribute the 4, and I get 8x plus 4 plus x squared divided by 3x cubed times 2x plus 1. And then you would try to factor if you can and cancel out common factors. It's not going to help because we get x squared plus 8x plus 4, which can't be factored. Divided by, you do not have to multiply out the denominator. You can leave it as 3x cubed times 2x plus 1. So our least common denominator was 3x cubed times 2x plus 1. Okay, you're not just adding in a missing term, you have to add in missing factors. And factors are things that are multiplied. All right, let's look at another one. So we have x plus 1 over x squared plus 6x plus 9. We're going to subtract 1 over x squared minus 9. Okay? So another way to kind of try to look at this is, let's just factor our denominators. Okay? So we're going to take x squared plus 6x plus 9, and we're going to write it as a product of linear factors. And we're going to do the same thing for x squared minus 9. Okay? So x squared plus 6x plus 9 is going to be x plus 3 times x plus 3. Okay, and then x squared minus 9 is x plus 3 times x minus 3. Okay, we need these to look the exact same. So to make them look the exact same, I have 1x plus 3 in both. I don't have 2x plus 3's in both. So I'm going to multiply here by x plus 3. Now I have x plus 3 times x plus 3, and then this one has an x minus 3, so I need to multiply this by x minus 3. Okay, so when it comes back up to the original problem now, we still have x plus 1 in the numerator and 1 in the numerator over here. So our least common denominator is x plus 3 times x plus 3 times x minus 3. To rewrite them, okay, this first rational expression, I had to multiply this denominator by x minus 3. So I'm going to have x minus 3 here as well. And then in the second one, I had to multiply by another x plus 3 to make them the same. So I need to multiply the numerator there as well. Okay? Then it's a matter of multiplying everything out and simplifying. Okay? So we're going to FOIL here. So we get x squared minus 3x plus x minus 3. We're going to take the negative with the 1. So we get negative x minus 3. And then the denominator is just x plus 3 times x plus 3 times x minus 3. And then simplify the numerator if you can. So we get x squared minus 3x plus x is negative 2x. Minus x would be minus 3x. And then negative 3 minus 3 is minus 6. And then we can simplify that to x plus 3 squared times x minus 3. And x squared minus 3x minus 6 can't be factored, so that would be our final answer. Okay, so unlike denominators, rewrite them with a like denominator, and then multiply by what was missing, and finally then you can add or subtract. Okay? All right. Second part of 9.5 is complex fractions. A complex fraction is kind of exactly what you're thinking. Okay? It is a fraction, and then it's got another fraction in it. So it's not just 1 over 2. Okay? It's complex. It's a fraction within a fraction. So in order to simplify complex fractions, you want to simplify the numerator and then the denominator and put them back together. Okay, so simplify, simplify, combine. So an example of a complex fraction is 3 over x minus 4. Okay, that's simple. It's just a one fraction. And then we're going to put that over 1 over x minus 4 plus 3 over x minus 1. Okay, so to simplify complex fractions, look at the numerator. It's 3 over x minus 4. Can we simplify that? No, we cannot. It is one fraction. Can't combine anything, can't cancel out. So we get 3 over x minus 4. Okay, then in the denominator, you're adding two rational expressions. So we need to make a like denominator. Okay, so what factor is missing here? Well, x plus 1 is missing. We're going to multiply both by x plus 1. And then what factor is missing here? Well, x minus 4. Okay, then we have to continue to simplify the denominator. Numerator can't be simplified yet. So we get, in the denominator, distributing the 1, we get x plus 1, and distributing the 3 plus 3x minus 12 over x minus 4 times x plus 1. Still in the denominator. Okay, so it's 3 divided by x minus 4. And then, simplifying it even more in the denominator, we get 4x minus 11 divided by x minus 4 times x plus 1. That is still a complex fraction. It's fractions within fractions. Okay, so what this really means is it means this numerator divided by this denominator. Well, how do we divide fractions? Okay, you keep the first, so keep the numerator. So that's 3 over x minus 4. Then change it to multiplied by the reciprocal of the denominator. So times x minus 4 times x plus 1 over 4x minus 11. And then simplify. Okay? But when you look, you have an x minus 4 in both numerator and denominator, so I'm going to cancel those. And then I can multiply here. So I get 3 times x plus 1, so it's 3x plus 3 over 4x minus 11. Okay, so a fraction within a fraction. Simplify your numerator, simplify your denominator, and then go back and put them together on what it means to be fractions, or numerator divided by denominator.